In this video, we're going to solve a certain 3 by 3 system of equations using those three elementary operations that we learned about in the previous video. Okay, so our goal is to take this 3 by 3 system and transform it into an equivalent 3 by 3 system where we can use back substitution. And remember, we can use back substitution if we're missing the x term in the middle equation and if we're missing the x and y terms in the last equation. Okay, and then it'll be fairly simple to solve, right, using back substitution. Okay, so how do we do this? Well, one of the things that we learned, one of the elementary operations we learned about is that we can interchange any two equations. It doesn't matter the order that we write the equations in. And for reasons that might become kind of apparent later, it's kind of nice if you just have an x up in the upper left-hand corner rather than a 3x or a 4x. It's nice to have a 1x. So notice this middle equation here, we just have a 1x, so we can interchange these two equations. Okay, so I'm going to draw a line here, and we're just going to do equation 1 interchanged with equation 2. Okay, so we're going to write this new system of equations where now the middle equation has become the top equation. Okay, and the bottom equation will stay the same. Okay, so we can interchange two equations. That's one of the elementary operations. Now, what if none of these had a 1x? What if they were all, like a 3x and a 5x and a 4x? Well, you would just take the first equation and multiply it by 1/3, right, to make this be 1. Okay, you're always allowed to multiply an equation by a constant, and so that's what you would do. Okay, well, we want to get rid of this 3x here first, and then eventually we'll get rid of the 4x and the 5y. So obviously we can't just erase the 3x or we'd be changing the problem. So what do? Well, we're going to take the top equation and multiply it by -3, right? We're going to do -3 times equation number 1. Okay, and we're going to add that to equation number 2, and that will give us the new equation 2. Okay, so take -3 times this equation plus this, that'll give the new equation 2. And notice if we do that, we'll be missing the x term in the middle equation. So let's rewrite the top equation. We're not changing the top equation, and also we're not changing the bottom equation, the third equation. But we are getting a new equation 2, right? We get a new equation 2. We get that by doing -3 times equation 1 plus equation 2. So let's do this term by term. -3 times x plus 3x, that gives you 0x. So notice that goes away. That's why we multiplied the first equation by -3. Okay, now next with the y's, we have -3 times 2y, that's -6y, plus another -1y, that will give us -7y. Okay, now -3 times this term, -3 times -5z would be plus 15z, and 15z plus a -z would be 14z. And finally, on the right-hand side, -3 times -8 is positive 24. 24 plus 11 is 35. Okay, so you see what we've done here. We've done -3 times everything up here and added it to the second equation. We got a new second equation. Okay, well, notice actually one thing that we could do, notice each of these terms in the second equation has a 7 in them, right? They're all divisible by 7. So let's actually do one of our elementary operations is you can multiply you can multiply an equation by a non-zero constant. So let's multiply -1/7 times equation 2 to get a new equation 2. Now why -1/7? Well, I want to just get a 1y here, so let's divide this by -7. So basically I'm taking every term in here and dividing by -7. It's the same thing as multiplying by -1/7. Okay, well again, the top equation and the bottom equation are going to remain the same. The only thing we're messing with here is the middle equation. And notice if we divide each term by -7, we just get a y there, and that's what we want. We would get -2z, right? 14z over -7 is that. And 35 over -7 is -5. Okay, so we got a new equation 2, right, on that one. All right, now let's get rid of this 4x in the bottom equation. Okay, one thing that we can do to do that, one way to get that is to multiply the first equation by -4. Let's do -4 times equation 1 plus equation 2, and that will give us a new I'm sorry, minus 4 times equation 1 plus equation 3. That'll give us a new equation 3. Right, so we're not changing the first equation. Even though we really are multiplying it by -4, we're not getting a new first equation, right, or second equation. Okay, but we are going to get a new equation 3, right? That's the new one we're getting. And what we're going to get is -4 times equation 1 plus equation 3. So -4 times each of these terms, let's do that. -4 times x would be -4x plus 4x, that's 0x. So notice we're missing the 0x. That was the whole point of multiplying by -4, was to get rid of the x's here. Right, I have a 4x here, so I multiplied this by -4 so that when I add them up I get 0. Okay, now -4 times 2y is -8y, plus 5y would give you -3y. -4 times -5z would be 20z, plus a -21z would be -z. Okay, and -4 times -8 is positive 32, and positive 32 plus a -31 is just 1. Okay, so you notice now that we're missing x's in the second equation and in the third equation. That's good. Now, how do I get rid of the y's in the third equation so that we can use back substitution? Well, notice we can multiply the second equation by 3. And if we do that, if we do 3 times this equation, we're going to have a 3y plus the last equation minus 3y, you'll have 0. Okay, so what we're going to do is we're going to multiply. Okay, we're going to do 3 times equation number 2 and add that to equation number 3, and we'll get a new equation 3, right? That's the new equation we're getting. So we're not going to change the top equation. We're not changing the middle equation, even though we really are going to multiply it by 3. Okay, but we'll just do that, and we'll do the calculation, so you're not really going to see the calculation. Okay, so what we do is 3 times this equation plus this equation. That'll be the new third equation. So 3 times y is 3y, plus a -3y, that's 0y. That's good. That was the whole point of doing this, is to get rid of the y's there. Okay, 3 times -2z is -6z, plus another -1z, that'd be -7z. And 3 times -5 is -15, plus 1 is -14. Okay, so notice we have a system of equations now just in the form that we want, right? So now we can use back substitution. We got rid of the x's here and the x's and y's here. Okay, well, if we want to solve for z, okay, using back substitution, well, we have -7z is equal to -14. If you divide both sides by -7, you'll see that z is 2. Okay, z is 2. All right, now if we go back into the middle equation and solve for y, we have y minus 2z is equal to -5. Well, we know what z is now. Z is 2. So we have y minus 2 times 2 is equal to -5, or y minus 4 equals -5. Adding 4 to both sides, what we get is y is equal to -1. Okay, and finally, we can go back to the first equation to solve for x, and we have x plus 2y minus 5z equals -8. So x plus 2 times -1, that's what y is, that's what we found y to be, minus 5 times z, but z is 2, equals -8. Okay, so what we have is x minus 2 and minus 10 is equal to -8. So x minus 12 is equal to -8. Adding 12 to both sides, what you end up with is that x is equal to 4. Okay, so our solution is really an ordered triple or an ordered 3-tuple. And the solution is this: 4, -1, 2, right? You do the x-coordinate first, then the y, then the z. Okay, so recapping, what did we do here? Well, we had a system of equations, 3 equations, 3 unknowns. By the way, you'd do a similar technique if you had 4 equations and 4 unknowns or more. And what we did at the very beginning, what we noticed was that we had one of these equations where we had a 1x, and that was good. So we decided to make that the top equation. We just interchanged these first 2 equations. Okay, that's what I did in the first step. And that's how I write it, okay, with a double arrow. Equation 1 is getting flipped with equation 2. Okay, once you do that, it's nice because then you can multiply this equation by -3 and add it to the second one, and it will get rid of the x's. because you'd have a negative 3x plus a 3x, that's 0x. You can also multiply it by negative 4 and do negative 4 times x, and we have a positive 4x, and add it to the third equation, and you will get a 0 there. Okay, notice also along the way what I did at one point. Sometimes it's nice to have this y end up being a 1y. So I had minus 7y, but notice each of these was divisible by 7, so I just divided everything by 7, actually negative 7, to make it a 1y. Okay, and finally, you get to a point where you're missing the x's here and the x's here. How do you get rid of the y's there? Well, you multiply the middle equation by 3. Okay, in this case it's 3 because it's minus 3y. So we have 3y plus minus 3y is 0y. Okay, and you do that and you get a system where you can now use back substitution. Okay, once you get to the back substitution, it's not so bad. Okay, in the next video we'll talk about using matrices. You can do this without having to write so many x's, y's, and z's. You can do it just using numbers, basically just using matrices.